Next up, we're going to look at solid objects. So solid objects are more complicated than point masses because instead of having just a handful of masses we have to deal with, we have an infinite number of them. So instead of using sums, we're going to have to use integrals. Now, not all solid objects are difficult to deal with. If you have something that's a circle, then finding the center of mass of this is going to be really easy. It's going to be right in the center. You can think of it as it's the point where the mass is distributed most uniformly around it, or it's the point where if you could balance it, where's the point that it would balance, and it's going to be right in the center. Same thing goes for something symmetrical like a rectangle. Center of mass for this thing is going to be right dead in the center. It gets more complicated though if you have an object that is not completely symmetric, and that's true even of something as simple as a triangle. If you look at a triangle, if it's a equilateral triangle, the center of mass is going to be right there in the middle. But if it's an isosceles triangle, the center of mass, you can narrow it down. It's got to be on the line of symmetry, but figuring out exactly where it is along that line can be a little difficult. What you have to do is figure out where can I draw a line across, so that exactly half of the area is below and exactly half the area is above. And one other important thing I should mention is all the stuff we deal with here is going to have uniform density. And uniform density is just so that we can treat the mass and the area as the same thing. So this example we've got here, it shows here's a semicircle with radius 3. Where's the center of mass? Well, it's definitely going to be along this line by symmetry. And we have to find the other place where we could put a line across there like this, so that half the area is above and half the area is below. It looks to me like that's probably fairly close, what I just estimated. I'm going to guess. I'm going to put a mark here on my guess. I'm going to guess that it's slightly above 1. I think I worked this problem the other day, but I don't remember the answer. But I believe the answer is going to be a little bit bigger than 1. So I'm just going to give you the formulas for this. The formula for the center of mass, or centroid, is given by this for x coordinate and this for the y coordinate. Now on the bottom it says total mass, but you could also think of that as being the total area. All right, so let's work it out using these formulas. I'm not going to do the x bar for this problem because we know by symmetry that x bar has to be 0. But let's do the y bar. Y bar is integral of 1/2 f of x squared dx over the total mass. All right, on this thing, the total mass, or total area. Now I could use an integral to do that, but we don't need to on this one because it's a semicircle. So the area is going to be 1/2 times radius squared, 1/2 pi r squared. So that's going to be 9 pi over 2. So that's our denominator. Now our numerator, what is f of x? It wasn't given to us on this problem, but it's a semicircle. It's the top half of the semicircle. So it's going to be square root of 9 minus x squared. So my y bar here is going to be integral of 1/2 of this squared dx over the total mass, total area, which was 9 pi over 2. Okay, what about my endpoints? My endpoints are going to be from -3 to 3. All right, so let's integrate this. Actually, before we integrate it, on the bottom we've got 9 pi over 2. On top we've got negative 3 to 3. And we've got the 1/2 I'll bring out front. And we've got the square root of that stuff squared, so that's just 9 minus x squared dx. And now let's integrate. See, up top I've got 1/2. I'm going to integrate this to get 9x minus 1/3 x cubed from negative 3 to 3. And I'm dividing that by 1/2 times 9 pi. Now I'm writing it out like that because I want to just cancel these halves. So on the bottom I've got 9 pi. And on top I've got, plug in the 3, you get 9 times 3 is 27 minus 1/3 of 27. Then minus, let's see, 9 times negative 3 is negative 27 minus 1/3 of negative 3 cubed is negative 27. I could have used symmetry to do this, but let's see. 27 minus 1/3 of 27 is 18. And this over here is it's the same thing but negative, so negative 18. So what we wind up with here is on top we've got 36 over 9 pi, which is 4 over pi. And 4 over pi is, let's see, I'm going to make this a squiggly equal. 4 over pi is my answer. So I'm going to write it out like this. Y bar equals 4 over pi. 4 divided by pi on my calculator is 1.27. Of course, it keeps going, but I'm just going to round it off there and use a squiggly equal. So my guess was 1.1, and I was off by a little bit. But I was right that it's a little bit more than 1. So anyway, these formulas are the key to doing centroids.